President and Vice-Chancellor, as public orator, I, Dr. Paul Jenkins, present Fiona Rayment, a candidate for an honorary degree. Fiona Rayment was born in Bellshill, Lanarkshire, Scotland. She attended Chatterhoe Primary School and Hamilton Grammar School. For her Scottish hires, she studied chemistry, physics, maths, geography, and mandatory English. She admits that the sciences were her favourite and that she did not enjoy compulsory English. In choosing a university, Fiona was attracted to the chemistry course at Strathclyde because it had applied options, including chemical engineering. Fiona had great fun in university, playing squash, showing her superb organisational skills when she became president of the Andersonian Student Chemical Society. The visiting lectures Fiona organised were based on the widest interpretation of the field of chemistry. The most popular were the chemistry of wine and the distillation technology involved in the production of whiskey. In the taster parties at the end of these lectures, it was clear that Fiona could organise a booze-up in a chemistry department. After graduation, Fiona continued to study for a PhD in inorganic chemistry under the supervision of Dr. John Morris. It was at this time that Fiona became fascinated by the idea that nuclear technology could benefit medicine and that nuclear energy was the partial answer to the climate crisis by enabling us to achieve net zero. During her studies, Fiona did part-time work as a supermarket cashier and pulling pints behind the bar in a pub. However, her first full-time job was with British Nuclear Fuels Limited, where she worked on methods for removing radioactive elements from liquid nuclear reactor effluent. The processes involved physical and chemical separation of elements in various oxidation states using water, tributyl phosphate, kerosene, and nitric acid as the liquids for extraction. Ion exchange and precipitation methods were also employed. Fiona went to work in Hanford, USA for a year. She found that American nuclear technologists were more advanced on some of the engineering aspects of the work compared to the UK, but that Sellafield was more scientifically innovative. On returning to Sellafield, Fiona became the business planning manager responsible for writing the BNFL strategic plan. Around that time, Fiona was talking to a close friend who asked her if anything was wrong, because Fiona was not her usual enthusiastic, bubbling self. After some reflection on her friend's question, Fiona realized that she was uncomfortable working so far removed from scientific activity. Fiona requested to move to product development, where she became very excited to work on mission-driven research and development. Alongside this new role, Fiona completed an MBA at the University of Manchester. Under Fiona's leadership, innovative solutions to problems in nuclear decommissioning, decontamination, and separation were achieved, which made BNFL second to none in the field. In the early 2000s, BNFL was privatized, with the R&D component being kept in government ownership. Fiona became a technical director within the R&D company Nexia Solutions, which then became the National Nuclear Laboratory. Her focus was on creating new fuels for nuclear reactors, together with recycling the used nuclear reactor fuel. At this time, Fiona and her team began a collaboration with Professor Richard Ambrosi at the University of Leicester Space Park, funded by the European Space Agency. There was a need for some means of keeping instruments between 18 and 20 degrees centigrade in space. The answer that Fiona and her colleagues found was to use the element americium-241, and the project had to solve the problem of isolating and purifying this element. In 2021, Fiona became the Chief Science and Technology Officer of the National Nuclear Laboratory. As part of this role, Fiona was also chair of the Nuclear Skills Strategy Group, which involved international work to define the skills necessary for a successful nuclear industry. Throughout her spectacular career, Fiona has always been a mentor of talented scientists to ensure their succession into important roles in the nuclear industry. She has also received a long list of awards and honours. In 2017, Fiona was awarded an OBE for her work in the area of research, innovation, and skills development in the nuclear sector. In 2025, Fiona won the Sir Frank Whittle Medal from the Royal Academy of Engineering for her lifetime achievement in nuclear engineering. In 2020, Fiona received the Légion d'honneur, the France's highest honour for work promoting links in nuclear education between France and the UK. This year, in January, Fiona was made Dame Commander of the Order of the British Empire, DBE. President and Vice-Chancellor, on the authority of the Senate and Council, I present Fiona Rayment that you may confer upon her the honorary degree of Doctor of Science.
President and Vice-Chancellor, distinguished guests, fellow graduates, ladies and gentlemen, I am deeply honoured and so grateful to receive this Honorary Doctor of Science degree here today. I thank the University very much for this remarkable recognition, which I accept with pride and appreciation. To be associated with an institution dedicated to the advancement of science, technology and innovation is a privilege. Receiving this honour is a tribute to the many people who have guided me and supported me and inspired me throughout the totality of my career journey. When I started as a scientist, I had no clue where I would end up or what jobs or roles that would define me. And I owe so much to my mentors, friends and family whose encouragement and belief in me have enabled this to be invaluable. We all remember good teachers, don't we? And they do shape us. I remember very clearly my chemistry teacher, who was amazing. And I guess I chose chemistry because of that, or maybe chemistry chose me as a result of them. I'm sure of that. Science has and always will be a powerful tool that enables us to understand and shape our world. Every scientific discovery begins with curiosity. The courage to ask questions and challenge our world assumptions. I was always curious, even as a young child, to the annoyance of my parents, who wondered, would I ever stop asking them why? I had that opportunity to apply that curiosity here at this university as we explored the possibility of using radioisotopes for power in space exploration using americium-241. And although I've explored many opportunities in my career through engaging in multiple roles that required varying degrees of science and engineering, I've enjoyed finding myself as part of this. For me, I realised over the years that no matter what role I did, my scientific background would always provide me a basis to analyse challenges, find solutions, and in doing so, make a fundamental difference. So, to today's graduates, today marks an important milestone in your life. Take time out to celebrate your achievement, and well done to all of you. You're entering a rapidly changing world that needs your talent and your ability to provide that analytical thinking to the challenges we face, which will be instrumental in our success. Continue to be curious, never stop asking why, and do not underestimate your ability to always make a difference. One more thing that I would say is find a mentor. Everyone needs someone to talk to bounce ideas off, to help create networks, and will sometimes just have your back. It may be one, it may be a few, but whatever the answer is for you, find a mentor to work with you. You'll never regret it. And with that, learn the importance of creating your successors. In this way, it will be easier to move on while leaving your legacy in place. Thank you once again for this extraordinary honour. I'd like to congratulate everyone today in their own individual successes and in the very bright future ahead. Thank you.